In this video, we will be starting our unit over matrices. And today, while I do have the notes combined for day 1 and day 2, this video is just going to be for day 1. I will make a separate video for day 2. A matrix is a rectangular array of either variables or constants that is arranged in rows and columns. And you can see an example of a matrix right here and how it is enclosed in brackets. Now each number or variable in the matrix is called an element, and each element is usually denoted by a capital letter, so this is called matrix A. Now a matrix is described by its dimensions, and those are its number of rows versus its number of columns, and it's always in that order. So I really want to stress that. And matrices are used to store either information or are used to solve some higher order mathematics. But you gotta know a couple different details about those matrices before you can use them to help you solve those higher order math problems. And we're gonna start with the basics in our video for today. It says for number 1, use the following matrix to answer the following questions. For number 1, it says state the dimensions of matrix A. Once again, the dimensions are always the number of rows by the number of columns. It's always rows and then columns. So if you look, this matrix has 2 rows, but 3 columns. So this is a 2 by 3 matrix, and a lot of times, the notation that they use looks like this. If it's matrix A, then they'll put that 2 by 3, it'll put the dimensions as a subscript. Now number 2 says find the value of A13. A couple things. That is a lowercase a, so that is referring to one of the elements in the matrix, but that's not a 13. That's going to be separated as a 1 and then a 3. So the 1 means you go to the first row, and then the 3 means you go to the third column. It's always row and then column, just like the dimensions. So the first row, third column, would be negative 18. Number 3 says find A, and then it's got this little t. This is called the transpose. So find the transpose of matrix A. In a transpose, all they are asking you to do is switch the rows and the columns around. So every row will become a column, and by automatic switch, the columns will become rows. And so if we look at the first row, it is 4, 9, negative 18. I'm going to make that my first column. So then the second row becomes the second column, and that is the transpose of the matrix. So they use this superscript to denote the operation. And number 4 here, it says take 3 times A. This is called scalar multiplication. So I've got the number 3, and I've got my matrix A. And all they want you to do here for scalar multiplication is literally multiply every element by 3. So 3 times 4 would be 12, 3 times 9 is 27, and you get the idea. So scalar multiplication is where you take some constant value and you scale up or scale down depending the values of your matrix. Here we're scaling up by a factor of 3. Some other important notes on matrices. Certain matrices have special names. For example, a matrix with 1 row, so maybe it looks like this. A matrix with 1 row is called a row matrix, and a matrix with 1 column, you can imagine what this would look like, is called a column matrix, or also a vector. Now, a matrix with the same number of rows and columns is called a square matrix. And it's called a square matrix because if it's 2 by 2 or 3 by 3 or 4 by 4, it forms more of a square shape as opposed to more of a rectangular shape. A matrix in which every element is 0 is called the zero matrix. I'm not really going to draw that out. And two matrices are equal if and only if each element is the same to the corresponding element in the other matrix. So not only do the matrices have to have the same dimensions, every element has to be the same in the same spot. They have to be exactly the same. But probably the most important part down here is that matrices can be added or subtracted if and only if they have the same dimensions. Okay, so if I have two matrices that have different dimensions, I can't add or subtract them. And the last part here, the trace of a matrix, and it has to be square, is the sum of the entries on its main diagonal. Let me show you what I mean here. So here is a 3 by 3 matrix. It is square. It's 3 by 3. The main diagonal are these numbers right here. So the main diagonal starts at the top left and it goes down. And the trace just wants you to add those together. That's it. Let's go ahead and flip to the second part of this the sheet. All right, so it says use the following matrices to answer the following questions. I've got 4 different matrices here. Let me go ahead and note their dimensions. Matrix A is 3 by 2. Matrix B is also 3 by 2. C is actually 2 by 3. And D is 2 by 2. Number 5, it says take 2 times A plus B. So according to order of operations, I need to add A and B together first, and then whatever that answer is, I'm going to multiply it by 2. So what I'm going to do is I'm going to add A and B and put that result here, and then I'll scale everything by multiplying it by 2. To add matrices together, they have to be the same dimensions, and you'll notice I already wrote those at the top. These dimensions are exactly the same, so I can do this. To add them, you literally just take the first number and add it to the first number. Take that second one and add it to that second one. And the pattern just continues. Just match them up in the same position and add them together. And as we learned from the front side, when you have a scalar out front, everything just gets multiplied by that scalar. And there it is. There's my new result. Number 6, it says B minus 3A. Okay, so I've got matrix B. Here it is. And I want to subtract 3 times A. Well, I don't know what 3 times A is, so I'm going to put that result here, and then I'm just going to subtract these 2 answers. So I'm going to go up to matrix A, multiply everything by 3. And it's up to you if you want to subtract these or if you want to change this to a plus sign and then add the opposite. So take the opposite sign of each one. It's up to you. Just watch your signs no matter what you do. But essentially, these are the same dimensions, so I can do some subtraction. 7 minus 3 is 4. 8 minus negative 16, I believe, is 14. Negative 3 minus 9 is negative 12. And the pattern continues. And there's your result. You can even put some algebra into the mix here. So for number 7, I have 4x minus b equals a. That is an algebraic equation, excuse me. That's an algebraic equation where they want you to solve for x. So I'll start by solving by adding the b over. And then to get x by itself, I'm going to divide by 4. And when you divide something by 4, it's the same thing as multiplying it by a fourth. So all they want you to do here is add a and b together and then multiply it by a fourth. So you have to confirm whether you can actually add a and b together first. If you couldn't, then the problem is just not possible. But we actually already added a and b together earlier, so I'll just copy my work from before. And then I'll just multiply everything by 1/4. So 8 times a fourth, 6 times a fourth, so on, so on, so on, and so on. And there would be my result right there. Now, the last part to this video just involves finding the trace of a matrix D. And so the trace of matrix D is, first off, it's a square matrix. And so the trace is just the sum of these numbers right here, because that's the main diagonal. So all they want you to do is take 3 plus negative 2, or excuse me, yeah, 3 plus negative 2, and that answer is 1, not negative 1. 3 plus negative 2 is 1. So that covers a lot of the basic information, and this is where the video is going to stop. But save this note sheet, as the second video that will follow is going to pick up right here. That's it.